Hello. Hi everyone. Today we're going to continue with a course on HCIA-Storage. Previously we've talked a lot about the development of storage technology, from a single disk, to multiple disks, to external devices, and then to disk arrays, as well as what we discussed in the last class about. On our side, we have network storage and distributed storage. These storage technologies are actually gradually improving, with larger capacities and greater convenience. The availability is also getting stronger. As for data protection, it's getting better too. This is really a basic development process of our storage technology, and it brings us to where we are now with distributed storage. Availability is getting stronger and stronger. Data protection is also getting better and better. This is actually one of our basic development processes of storage. In fact, it has come to this here. Distributed storage. On the network storage side, we are still using it as of now. All of these are still in use, including what we talked about earlier, which is RAID. So, these technologies aren't completely obsolete. They're all still in use. RAID is essentially a foundational configuration, meaning that all the disks at the bottom level can support RAID. They can all support RAID. And next, we have network storage. In fact, once we started using network storage, our storage has been inseparable from the network. You can think about what we have later. Does distributed storage need a network? Yes, it does. How would you connect without a network? And now we come to what we're going to talk about today. Virtualized storage. Has a very high correlation with network performance as well. So you definitely need a network to connect. Now, what exactly is the role of virtualized storage? First of all, you can see that this is our bottom layer. Here, in fact, it is still physical resources. This communication relies on physical resources. Even though we call this virtual storage, it's not something that just appears out of thin air. It actually exists. The foundation is physical resources. But we don't use these physical resources directly. Instead, on top of the physical foundation, we add what? We add a management platform. We add a virtual layer to control our storage. At the bottom layer, all the physical storage here has fewer limitations because, as you can see, we've drawn 4 illustrations. We have a regular disk, right? We have server disk arrays, and so on. Of course, we can also add what we talked about earlier. Network storage, and distributed storage. Next, let's talk about whether this is okay. Of course, it is. Here, our virtual layer is essentially what? It's like managing all the underlying physical resources. These physical resources are not affected by what? Well, they are not influenced by their types. It's different. Various storage forms and different devices can all be managed uniformly. This is one of the advantages of virtualized storage. With virtualized storage, actually, we can... When it comes to storage expansion, first of all, it's much more convenient, right? Secondly, there's basically no downtime, and it's easy to manage. This is actually an advantage of virtualized storage compared to the previous types of storage. Of course, the earlier types of storage can also be expanded continuously. But from the user's perspective, our disks are seen as a whole, as a single virtualized disk. It's essentially just one disk. At the bottom layer, no matter how much you add, from our perspective, it still looks like just one disk. This way, it's easier to manage, and for users, it feels much smoother to use. Here, it essentially hides what? Its benefit lies in the fact that it can hide the complexity of physical devices. At the bottom layer doesn't matter, no matter how many types or how complex they are. We can directly manage them in a unified way through this logical representation, which makes things a lot more convenient. And of course, the expansion is the same. Since it is already after network storage and distributed storage, of course, there is no problem with its expansion. Its expansion is that you add a new storage resource, any kind of storage resource, to our overall virtualization level. We are equivalent to virtualization. If you don't understand this, you can. Let's draw an analogy with the LVM logical volume in our Linux system. LVM logical volume, What about this logical volume here? Its main function is to combine multiple different disks, or multiple different partitions, into one virtual disk for use. As a virtual disk. So here, we can do the same thing. We can also combine different types of storage resources, putting them all into one disk for use. This way. Expansion is also convenient. right? Allocation. This is also quite convenient, and you don't have to worry about which drive is getting full, or which one doesn't have enough space, and so on. That's one of the characteristics of our storage virtualization. Well actually, the benefit lies in what? The benefit lies in how convenient it is for us to manage things. It's also easy to use. This is like an upgraded version for us. Hey, it has evolved from our distributed storage to virtualized storage. Of course, it's not over yet. In recent years, or let's say it really started to gain traction about 10 years ago, and in the last 5 years it has developed very rapidly. The content is our cloud services. There are actually quite a few components included in cloud services. What about some of your other cloud services? In another course, which is the cloud computing course, we will cover that. In this course, we mainly focus on storage. The content about other cloud services will be discussed in the cloud computing course, okay? So this is cloud storage. As the name suggests, it's storage in the cloud. So, when it comes to cloud services actually, what is it? Cloud service is actually the same as what we mentioned above. What about virtualized storage? There is a certain connection. What is the connection? Basically, all our cloud services, whether it is public cloud or private cloud, in our cloud services, most of them basically use a form of virtualized storage. The form of virtualized storage uses virtual machines, which is what we typically use in some cloud services. So, why do we use virtual machines? First of all, creating virtual machines is easy, and they use fewer resources. And you don't need real physical servers. We can deploy dozens of them on the same physical server. If your resources are particularly high, you can even have hundreds of them. This is the overall advantage of cloud services. Cloud storage is one type of our cloud services. It's one of them. Here, our cloud storage is actually it's about integrating multiple storage devices, multiple applications, and multiple services into a cohesive whole, a complete integration. First of all, its underlying structure must definitely have virtualization. The underlying must have virtualization. What does this include? It includes, by using our traditional or general hardware platforms, we can combine our physical resources together. Here we can divide it into a few different types, including file storage, block storage, and object storage. These 3 types of storage are part of the cloud services. So, the 3 main types of cloud storage are block storage, file storage, and object storage. Then, for customers, we can provide these storage interfaces to users, allowing them to directly call and access the data. Of course, this also requires a network. It all relies on the network, i.e., this is what we call our cloud storage. As for the cloud column, of course this is actually... generally speaking, cloud storage is usually used in conjunction with other cloud services. It's actually quite rare to use it on its own. If you were to just take cloud storage by itself, it's not very common. Most of the time it works together with other cloud services, like other cloud servers, or cloud databases, and so on, working in collaboration with them. This is basically a fundamental characteristic of cloud storage. Here, it can actually serve mainly, well, the target audience is actually, what is it? It's primarily individuals, or rather, it's mainly aimed at businesses, primarily at businesses. To provide scalable storage resources for businesses, and it can be dynamically configured according to the organization's requirements. Here, some of the storage actually, a lot of storage can be what can be. There's a payment model called pay-as-you-go. With pay-as-you-go, you only pay for the storage you actually use. If you use less, you pay less. If you use more, you pay more. Plus, it can be expanded at any time, which makes it quite convenient to use. This operation is completely automated. We just need to purchase this cloud storage, and then you can essentially use this storage space infinitely. You only pay for what you use. This is a fundamental characteristic of our cloud storage, the basic feature of cloud storage. The above is actually our overall development process of the entire storage, from 1 to 2 to 3, to arrays, to clusters, to networks, and to virtualization to the cloud. This is actually our process. The overall development history of storage, the Overall development history of storage, to be precise, is the complete development history of storage architecture. Alright, that's it for this lesson. If anyone wants to learn about Huawei certification technology or wants to access Huawei certification question banks, please feel free to message me. You can also leave comments below the video for technical discussions. Okay, that's all for today.